Okay, you can put.
Okay.
Okay. Are we good to go?
Yes,
all right,
please.
so
Yeah, we are good to
so
go.
all right, so let's regress TFP as against GDP growth, export, import, net export, infrastructure, education, health, defense, government expenditure. We are running all. Now, you can see this result here. And then let's perform the VRF and see. Okay. So can somebody just look on this screen as you are saying and interpret the VRF and tell us what is actually happening over here? So, Madam Sharon, hey, today the sun is on you. The sun is on you. What can you tell us about this in conjunction with the VRF? And then Mr. Edu also should be prepared to tell us something. Mr. Edu, what can
Yeah,
you tell us? Now, let's go
yes,
to
Doc.
Mr. Edu first. Mr. Edu, Dr. Edu, tell us what's your take on this? Whether you like it or you finish your PhD by this one day.
Yeah, I can see
Tell me what you
I can see a mean VIF of 540.17. And
okay.
yeah, but I can see it being strong with export, education, and infrastructure.
Okay.
Yeah. So
So,
basically, yeah.
so this result, is it good? Is there any problem in it? What do
Uh,
you advise? Is there any problem in this result you are seeing here?
uh, if I'm correct, I can see it's good with the the GOV export and education and infrastructure, but the remaining four variables, import, net export, defense, and GDP is not. Yeah.
Defense and GDP is not.
Yes, please.
How do you come by this?
Yeah. If I remember, last time you gave us a threshold. Yeah. Uh, but if I could remember well, then the remaining four fall short.
Okay. So you are saying that import, net export, defense, and GDP as their uh, VRF, there's a problem, or government expenditure, education, infrastructure, that's where the problem is.
I think the problem will be with the four, the last four.
The last four. Okay.
Yes, yeah.
All right. So that's your take.
Yeah.
Okay. So we document your take on it. Now let me go to Madam Linda. With this, is there any problem based on last lecture? Yes, please.
I think so.
You think so? Okay. How are you making it? We want to actually appreciate the lesson, so that's why I'm taking us through one by one for us to appreciate this too well. What do you why do you think so?
Looking at the threshold that you gave the other time, So when you use that, it means it's above them. So
which one is above them?
the mean VIF.
Okay, the mean VIF is above.
It's
So
above
there
10.
is.
It's greater than 10.
So it means there is what? There is a problem.
Yes.
Okay. All right. So Madam Linda said there's a problem there. Mr. Tutu, you just joined, but you are welcome. So looking at the VRF of this regression analysis we just performed here, the VRF here, is there any problem in the whole results? Does the problem face, what kind of problem is this? What kind of situation is arising from this result? Madam Maureen, please, what do you think is the situation here? What situation is arising from this result?
I can see there's a problem in VIF2 because the threshold should be below 5.
Okay. The threshold should be below 5. Okay. That's okay from your side. That's okay from your side. All right. So I will bring in this for us to judge ourselves here. Okay. Now, let's look at this side here, the summary of key diagnostics in our result. Summary of key diagnostics in our result. Here, we say that the VRF should be what? What's this?
Less than 10.
Less than what? 10. A VRM should be less than 10. Okay. So from this, the VRF should be less than 10. Since the VRM is above 10, there's problem. But individually, import, net export, defense, GDP growth are okay here. Now, so which could note that there is a problem of multicollinearity in the data. So we need to work on it. And it will affect our judgment. It will affect our definition. It will make the coefficient unstable. So it is important that you work on it, clean it, and make it work. All right. Per the analysis for this particular data, all these variables, majority of the variables were used as dummy, or used as control. Hence, that's why you are seeing it that way. So we need to actually look at our data well before we perform any other analysis, before we run any other analysis. That is how we do it. Okay. Are we together? All right.
Yes,
Today,
please.
I want us to take us a bit advanced to what we call structure equation modeling. Structure equation modeling. Structure equation modeling, it's also a form of analysis or a technique used basically to actually enjoy structure equation modeling. It is basically advised when you are using a panel data, a cross-sectional data, and then the cross-sectional, if it's a longitudinal, it's also okay. But we can also use STATA to perform a structural equation modeling. We can also use STATA to perform a structural equation modeling. And it is when you go to STATA version from 15 and above, the upgrade for structural equation modeling, it's also similar to that of Amos, and then I think a bit close to Smart PLS. But from 10 to 14, it is a standard structural equation modeling. Now, with structural equation modeling, we talk about latent variables, we talk about constants of variables, we talk about constant of variable. So in this regard, I will perform simple structural equation modeling for you to see how it is done, okay? How it is done. And it is important that we understand, we learn it, and we become familiar with this. Okay. Any question before we go to structural equation modeling? This is a general regression analysis that you can apply AR, DL model, you can apply fully modified, you can apply ordinary DOL dolls, you can apply all the forms or the various level of regression analysis. You can, yes, auto regression analysis you can perform with this basics one. Now, and I believe some of you, your analysis of your thesis or your papers, you are doing something SEM. You are doing something SEM, and you are disturbed that, oh, you don't know how to use Smart PLS, you don't know how to use Amos, you only know how to use STATA. This STATA can also help you perform structural equation modeling. Are we good to go? All right.
Yes, please.
All right. So basically, we are also still going to use this same variable to try it. Now, please pay attention as I go. I will slowly do it for you to see. Now, you first come to statistics. This one is also a system build one. It's not necessarily command based. Okay, system build, but when you want to run other goodness of feeds and all of this, you can actually perform it. But this is also a very good one. So you can just go to statistics, and then you come to the drop-down menu. You see it here, SEM, structural equation modeling. Structural equation modeling. And in this regard, you build your model. In this regard, you build your model. Sometimes you can build it with latent, because structural equation modeling, basically, if you want to get that of the Smart PLS one, you perform it separately, and then you can get the result. So you have it here, like the structural equation model, then you build your model building and estimation. So under you have testing of CIS, goodness of it, group statistics, prediction, and all that. So when you come to this place, you can see that each of them, modification index, score test, and the equation level Y test, direct and indirect effect testing, standardized parameters, likelihood ratio test, Y test of linear hypothesis. So all these things are also performed using STATA. So you don't have to limit yourself, that you don't have to be stranded that I don't have Smart ELS, so I can't perform it. You can actually perform all of those analysis in this software. So we build a model here, build the model. Now, when you click build the model, you see an interface opening for you. Now, look at the interface that opened for you. So you see this interface. You have all this one. You have the GES, structural equation model, general, or change to generalized model. You can change it to generalized model. You can perform it with observation. You can perform it with generalized response variable. Now, you can also add the latent variable L, and then you can also perform the multi-level latent variable analysis with it. So you can see that this software can also help. And then here, you can perform it with measurement component. The measurement component, that's talking about the constants coming up with it. And then all this, you can perform a direct effect regression component. So we can also use the structure equation model to perform a direct effect. Now, let's start by trying to use the structure equation model builder to perform a direct effect. So what you do is that you click it. Now, when you click, you only have the arrow to perform. So anywhere you put your arrow is there. Okay. Now, in this regard, when you click it and then you bring it to the work sheet, you have the dependent variable asking you to estimate the dependent variable, to call in the dependent variable. In this one, you see regression components, main, distant, connection, then dependent variable, and then all what have you. You have selected variable, you have all this. So let us try it and see how it works. Now, the dependent variable, as we are saying, first it says total factor productivity. Now, we are just trying to try, we are going to just try the first one, and then the independent variable. So we go by just GDP growth, export, import. Let's use these two, right? Let's use these two. Now, in this whole thing, it can ask you to point to where you want the direction of the path to be. The path is where the arrow goes. It has to go to the left, the right, down, up, or whatever, right and left, and all those things. But now let's leave it on the left. And then after calling in the variable, the dependent and independent variable, you can just say okay. Now, here, so you see, everything is set here. It's okay here. So we can only try to estimate it and see how it works. The one thing about structure equation modeling is that it gives you the stochastic, the error term direct when you perform the analysis. Now, so we take off the equation building up. So we are okay. Now, I just want to enlarge it for you to see well. You can just drag and then enlarge anyhow you want to enlarge. Now, from this point, you can see that I also have the dependent variable, the independent variables here. Now, all these variables are already built in it, okay? I can also as well decide to change the variables in the equation. When I click here, it tells me that variable. I can change it. I drop down, I can change the variable. Okay, that's one. Or I click here, change and drop the variable or change the variable. If you want to change the variable, you only have to click it, come to the drop down here, call it a different variable. The same thing here, come to the drop down, call a different variable. So basically, the model is built here. We have built our model. Okay, we have built our model. Basically, I said the last time that when you are building model, make sure your model is in line with theory or is in line with literature. Support your model and your theory. Your model should be supported with literature and theories. That makes your work correct, concrete. Sometimes some people just write something, and when you check, there's no model, there's no theory backing them. It's like they are just creating an island. It also affects your thesis, affects your paper, and affects your proposal. So make sure a model back all your theory, or your theory or literature backs all your models. Now, everything is set here. So I go to estimate. So here, structure equation model in STATA also give you ability to estimate. You see, so you just come to estimate. You click the estimate, and then it's pointing to you that you can estimate, and then you click here. I take it again. You want to estimate, just come to estimate or run it, estimate, you click it. Then, yes, so the information is already in the system. Now, it's asking you, the structure equation is asking you what kind of a thing or the operations that you want the system to perform for you. So basically, you can either perform maximum likelihood, minimal likelihood with missing variable, or all those things. So right now, it is set. So what you have to do is just to click. You see, you have group in, if and in, weights, RL, robustness, and all these things. So you can click the robot, default standard, clustered robot, expected information mix. All these things can be operated. The bootstrap, knife, and all these things can be done using the structure equation model in STATA. So do not be discouraged that you have to go and learn smart PLS before you do structure equation. You can actually do the structure equation here. Reporting formats, we already agree on 95% confidence interval, display standardized coefficient that value do not report. All these things, maximum, advanced, and all, everything is set here. Everything is set here. If you want to convert a structure, you can create the model here. You can as well create the model. You just click here and then you create the model you want to create. But now we are not about to do that. So we just want to perform the simple one. So we come back to our model and then we say we are okay. Now, when you check the whole result, the whole thing, it is still running. It's running. So sometimes when it's run, you can see that the results are printed here. The results are printed here. Now, it tells me that GDP growth to total factor productivity is 0.001. Export to total factor productivity is 0.0031. And then import to, this is negative 0.014 with a stochastic and error term of 0.0008. Now, when you click this whole, when you click, you want to check the result. The results can give you two forms, the unstandardized and then the standardized. Now, basically, this is the unstandardized result. So on the other side here, on the left-hand side of the screen, you can see the coefficients here of the beta is 0.001. You see, the standard error is the Z. This one bring you the Z statistic, the p-value, the lower and the upper, okay? And then when you go to the standardized coefficient, now we have the first box we see here is the unstandardized coefficient. The first box you see here is the unstandardized coefficient. The second box is the standardized coefficient. You see, it's a standardized coefficient, which is telling us that with the standardized coefficient, which means the information you put in, asking you to do maximum likelihood, including missing, not to touch the missing variable, that's giving you a standardized. So this one is accepted. You can operate with it. You can do operation. You can report it. You can actually talk on it direct. Okay. All right. I get it, sir. So I'll not disturb you today, my brother. All right. And then after the class, I need to call you, and now we have some talk. So, sorry for that, ladies and gentlemen. So you can as well click. You want to view. You see, when you click here, it push you to the result. When you click here it push you to this result. When you click here, it push you to this result direct. You see here, one thing is telling you that it's giving you the stochastic direct. It's giving the stochastic direct. It's telling you straightforward that this one is giving you the disturbance term. Okay. All right. Thank you. No problem. will give you the disturbance term direct. Now, when you come to the whole up here, you click view. It tells you either you zoom it in, zoom out, fit in the window, adjust, show. So when I click here and I click, you see it give me clear, no space. But I just want to continue to have my work. So you see, show estimate and the show standardized estimate. Please pay attention to the variables here, the figures here, the values here. But when I click show estimate, show standardized estimate, you can see that the variable change. Previously, when you look at this, it was 0.006 as here.
Wow.
And then with the standardized, we have 0.15. With the standardized, 0.15. Here, the standardized was the unstandardized was 0.003, but with the standardized is 1 point this. The same thing, the standardized for import is this. And so you can see that even the stochastic also changed. The stochastic, the error term here, the error term also changed.
Yeah.
The error term also changed. So, gentlemen, ladies, now we can also go back to the output view. Now, when you come to the output view, you can see that it's written here, structure equation modeling, right? Okay, interaction of 0, long likelihood is negative this. And then the interaction of 1, the long likelihood is also like this. Now, it accepts that we have this variable. And then estimation method is 1. The structure equation model, everything is shown here. Now, when you come to this place, it is giving you the direction of the pathway of GDP to TFP, export to TFP, import to TFP, and then the cost down to TFP. Now, you can see the result it's giving you here. This is the unstandardized result. This is the unstandardized result. And then with the standardized result, it shows us when we went to the path. We can also see it. Now, the variance or the explanation, the error term based on the TFP is like this: 0.001, this and this. Okay, and this with the upper and the lower boundary. This one has nothing to do with the significance of it and all those things. So basically, you can as well actually use this to perform a structural equation modeling. Any question, comment before we move to another level of structural equation modeling? Any question?
Hello, doctor.
Yes, please.
Okay, may you go back to how you can adjust the model? And then when you are reporting, or should I wait for the reporting time? Which one should you report? Is this the standardized or the unstandardized? Yeah.
Any of the reports you write, you have to support it by literature that you are reporting the standardized based on this. So you can report the unstandardized or the standardized, but support it with write-up. Okay, so
Okay,
I should
thank
go back
you.
to adjust.
Yeah, how to
Okay,
adjust
so,
the model.
Okay. What do you want me to say, ma'am? You want to adjust the model like this? or change the variables? Are we together?
Please,
Yes, sir.
for me, my arrow is still plus. So when you click on it, it will run and tell you to choose the variable. So I'm not able to adjust it. You see,
Okay.
your pointer is different from our own. I don't know if they are also fine.
Okay.
I'm unable to adjust it.
Okay, so this is what you do. This is what you do. You see the GESEM?
Yes, please.
You see the arrow down there?
Yes, please.
Please click it and go back to your worksheet.
Okay. It's working now. Thank you.
It's working now, eh? Okay.
Hello, sir.
All right. Yes, please, Mr. Edu.
Yeah, please on the output interface.
Yes, please. This one.
Yeah, on the actual STATA interface. Output.
Okay.
Yeah.
Okay.
I need some clarifications regarding the iteration 0, the log likelihood, the iteration 1, their meanings, and when you under the table you also see LR test. So please, can you help me with them?
Okay. All right. So the LR means the linear regression test of the model versus structure. Linear regression test of the model versus the structure chi-square.
Okay.
Okay.
Yeah.
So
Then
the iteration 0 of the long likelihood of negative 300.87 is this. It is telling you that when the equation was running, right?
Okay.
Because we key in to give us likelihood if there will be any bias, if there is any other estimation that might occur. Okay. Or the total running of the variable, total figure, the number of operation the system will perform to come up with a result for us. Likelihood is negative, which is not a problem.
Okay.
You don't have to pay much attention to it anyway.
Okay.
Your concentrations are here.
The structural equation. Okay.
Yes, please. Yes, please.
Okay. Okay. Thank you, sir.
Okay, but I don't think we finished Madam Maureen's question. Let's come back to her. Sorry, ma. So, Madam Joanne, are you okay are you able to run it?
Yes, please.
Okay, so you've gotten this result we're having.
Yes, please.
All right. Okay. Madam Maureen, are you okay?
Trying to adjust, but it's not like it cannot adjust.
It was the adjustment that you were worried about.
Yeah, on the model itself.
Adjustment, I think. We didn't answer your question, right? Mom, we did not answer your question, right?
Am I supposed to drag like these the triangles if I want to adjust them, maybe to make the model look at least bigger, or like should I zoom in, or what do I do?
Like you come to view it and then you zoom in like this?
Like to make not actually to zoom it, like to adjust the, let's say, the
size.
triangles. Yeah, the size.
Okay. This one, it's already built in the system. Okay. Now the one that will zoom out ourselves, I will draw it and then we'll zoom it ourselves for you to see. Okay.
Okay.
Now, let's open another worksheet. Okay. So in this work file, I can decide to draw it by adding variable myself. So I click here, I bring the box. Okay. And I put the box here. I also put the box here. Put another box here. Okay. Now, then I want to fit in the arrows. Okay. I want to fit in the arrows. I just pick the arrow here, the direct path arrow. I click here, and then I bring it down here. Okay. Then I only need 2 explanatory variables. So it's here. And I come back to it. Now, there is no path to expand this triangle again. You see, it is already static. It's built in it like that. But if you want to transfer your analysis to Word, the only thing about this is that you have to redraw it with either Drawbox, something draw or Visio. Okay, you can copy it direct like this and go and paste as picture or whatever. But basically, one thing about the STATA is that it doesn't pull the result direct for you. You have to draw it yourself, or you can save the result direct and keep it there like that. It doesn't care. That's not about beauty aspect of it. If you want it to be beautiful, you draw your own. You draw it yourself, like using Visio, right? Like using Visio. Madam,
Okay.
is that a question? You get it, right?
Yeah, it's okay. It's okay.
All right. So you see this one, if we make it like this, we can also add our own variables here. So what we do is that you click it, you call in a variable, right? You call in a variable. You see variables here, you click it, and then you call it another variable. Then you call in a dependent variable yourself. And then it's ready for you to run. Then estimate, go to estimation, you click it, and it asks you, would you want to perform maximum likelihood? Yes, then you click it, and then you are good to go. So you see it's running, and we have the result here. We can view it in a standardized form. That's how it is. Now, please, are you okay with this? Before we perform the constraint one, there is one, you see when you check Smart PLS, you have the variable and then you see constraints there, this one pointing it constraint. Okay, let's try and perform that one too.
Hello, sir. Before you proceed, I was
Yes,
trying to practice. So I lost track with the error term. Did you bring the circle yourself and connect it, or that one appeared?
No, please. No, please. When you just, so again, this is how it is. This one, I decided to draw it myself.
Yeah.
I put it here. And I put this one also here. The explanatory variable. This one also here. Then immediately I connect the path.
Okay.
Right? Yeah. When you click the path, then it push the error direct. It's a system. See the error appear direct.
Yeah. Oh, okay. Yeah.
When you click the path, the error appear direct.
Okay.
Are we okay?
Yes, please.
All right.
Thank you, sir.
Mm-hmm. All right. Now, there are sometimes the structural equation modeling we have something like this. So we want to check the measurement variables. Let's say, for example, we want to check import or net export. Let's say net export. What are the constraints of net export? So net export, we can talk of import and export, or some of your explanatory variable, the explanatory variable you are using. The measurement variable that constitute or that form your explanatory variable, we want to check how they actually relate, how they actually correlate, how they actually relate or match or define or explain your independent variable. We can perform it using the STATA structure equation modeling. So this is where you come. Now, when you look at this place, you have some arrow like this. Okay. Are we all here?
Yes, please. Add
Also, when you
measurement.
click it, variable measurement, when you click it, right? You click variable measurement, you see the arrow tend to be plus sign. Okay. Then you click it in the working file. Now here, it tell you that latent variable name. The latent variable name. Okay, the latent variable name. And then observation level latent variable name, standard, multi-level standard variable name, all these things. So let's say the latent variable name, let's say I want to name it at net export. So I'll say net, I can just name it net exp, net esp, net p, yeah, just something like that. Okay. Now, I want to, maybe in your data, you have the constant for your variable. Let's say we want to talk about gender. Gender is equal to this. Gender is this. Then what form the gender? Male, female form gender. I'm talking about the gender we all know as Africans. Male, female, that's the gender we know. Now, and then we want to say let's say now, okay, so let me bring it back to the data that is available for us. We know that export is a result of net export is a result of my import minus export. Okay, now we have it here as, let's say, import and export. Okay, that those two, only those two, right? So this is going to be the measurement for our net export. Then we specify the number of variables. It's okay. Just leave it like this. And then do not estimate constraints. We have to estimate constraints. Sometimes it will ask you to not to estimate constraint. When you click it, to not estimate the constraint for you. But this one, we are interested in the constraint. We want to know the constraint. So we can point it to the right or to the left. Okay, it's already at the right. So there's distance, leave it like that. If you want to change it to the letter variable measurement to be more inches or whatever, leave it like that. The connection, it's already attached at intersection of the line and point. It's okay. It's already built in a system like that. So you just say okay. Now, immediately you click okay, right? Immediately you click OK. You see this thing here. This thing here. You click, you see this thing here. Then we want to estimate it. We want to actually make it look beautiful, estimate it. So we take off the highlight off. So by clicking this, the highlight is off. Now, so those who have done smart PLS before, you come across these things. So you can also estimate it. It's a matter of estimating it. So we estimate we estimate, and then we click. It tells us of the likelihood, much more likely. We say yes, and let's see how it's worked for us. Now, in working for us, I just hope it works because this is not a constant measurement issue here.
It fails.
So it fails. Yes, it fails because the data we are using is not for that. It's not built for that. I will call in a different data, right? I'll call in a different data and run it for you to see. And let me see whether I can share. Let me call in a different data. So you can see that when you come to the variable, the output, you see this whole likelihood is talking about. It's saying all these covariance, plenty. So to prevent it, you can just cut it. Come to the cut here. You break it here. Okay, you break it. Now let me call in a data that actually can do the structure equation modeling for us and see. That data, I'm sorry, you don't have it. Okay, so I've called in that data. All right, so I'm going back to rebuild the model. Now, please follow me as I build the model again. Those of you who have, wish I can share this data. It's a do file. When I share, you can't get it. So I'll use 1, 2, 3, 4, 5. Okay, so I just want to just show us something. Then I perform it. Now you can see this one. I included about 5 constants to the whole thing. So all right, so let me try and estimate this one. I'm sure it will work because this data has an explanatory definition on it. So I just estimate. Much more likelihood. Okay, let's wait and see if it should run. So as it's running, We can also perform a mediation analysis with this with a structure equation modeling, the STATA version of it. I would want us to see us the way it's run. Okay, let me reduce the construct and see. Why is it running so slow? Sorry, I'm coming in. Let me fix in a different. I don't know why it's not running. Mine is not responding, so please and then before we continue, please this thing is shared. Please, the timetable is shared on the attendant is shared on it. Please scan and then perform your attendance. Okay, so gentlemen, I'm recalling the data to see why it's not running. Okay, so oh, good. All right. Okay. Sorry for that. That's the data was having issues, so I'm okay. Okay, so you see, now you see from this angle, performing the structure equation modeling using checking for constants, the measurement variables, we can also see that when you use checking for the measurement variable with latent, right? You can also perform it like this. Now, we can also decide to use the standardized on the unstandardized one. Now, from this whole thing, it means that if I say this is growth, right? Growth. And I'm saying that about 3 constants that are used to measure growth, or how I measure the independent variable GDP growth. Okay, I'm measuring the independent variable, which is GDP growth, with either inflation, exchange rate, or export or duties, inflation, exchange rate, or real interest rate. Okay, if that is how I'm measuring my variable, or I'll say that this is this, and I'm measuring it with intermediate import quality, government subsidies, foreign ownership. All these things measure my GDP growth at intermediate import quality, measure GDP growth, contribute to GDP growth at 0.79%, and then that of the government subsidies contribute to negative 2.6%, and that of foreign ownership contribute to negative 93%. With these are the error terms. So we can also perform the measurement variable constants with the structure equation model built in the I would say the STATA, or say the STATA. So how you perform it is just to go here, click it, put it here, and then you can call in the measurement variables. So if I'll say this is gender, and I'll say this is male, this is female, this is male, this is female, and I click it. These are the total amount of the things that. So you can also perform it if you want to polish your data, factor loading side. You can also use to perform factor loading, how they are loading to each other, how they measure this. You see, when you are doing smart PLS or MOS, you say factor loading. You do the factor loading, come back alpha, AV, whatever. All those things you can also we can also perform it using the STATA to run all this analysis. Okay, so ladies and gentlemen, we can also use this time to do the constant measurement or measurement variable. But before we go, let's perform one mediation analysis so that next week, next class, we'll do a general analysis and how to apply the analysis, how to apply the research, the analysis to report, application of all this to research. We'll have to do it together. But today, finally, before we go, let's do a simple mediation analysis. Okay, simple mediation analysis. I'll go back to the data we used first. So that you can say, I use this one to show something. So I'll go back to the data that we use, the data that you all have. so that when you are performing, you can see. So please.
Hello, sir.
Okay. Yes, please.
Please, I need some clarification.
Okay.
Regarding the PLS, I'm also in that class, and I heard that in the PLS interface, the independent variables are on the left, and the dependent variables are on the right. So you always create the link from the independent to the dependent. Yeah. So with what you are doing now, if I saw it, the L, which was mapping to the government subsidies and all that. So the government, those that you are mapping to, are they the independent variables?
Okay. This is constant measurement variable. But what you are saying is, well, let's do it here. Let's do it in the second one I want to do now.
Okay.
Let's do what you are saying. Let's do it here now. Okay. So we call in the structure equation model again. Then we build our model. Now, in building the model, let's build our model here. Now, we say this is our dependent variable. Okay, dependent variable. And then these are our independent variables. These are our independent variables. Okay. These are independent variables. Now, we are matching it. So when you look at this, the dependent variable is on the left side of the screen, right? Not the right side of the screen. The dependent variable is here, the independent are pointing you to this.
Okay.
Yeah, they are pointing it to it. So we call in the variables as we did first. We call in the variables as we did first. Okay, so yeah. Then let's estimate it direct. Let's estimate the direct effects, and then we'll check the mediation effect as well. Okay. So we run the direct effects. Okay, so the direct effect is here. We've seen the direct effect now. Okay. Now, we want to perform a mediation analysis. And let's use a variable to perform the mediation analysis. So from this angle, we can draw another variable here. Okay. Then we join the variable. So you see, now for mediation analysis, the mediator become a dependent variable. The mediator become a dependent variable. So this become a dependent variable. This become a dependent variable. And then the mediator also mediate direct relationship to the original independent variable. Okay. Now, have you come across analysis like this before? If this is your first time of seeing this kind of analysis drawn in the system, have you come across it before? Okay.
Yes, please.
All right. So all right. Okay. So let's invite a variable into it and see if that variable can mediate the relationship between import, export. Let me just think of any variable. Let me think of health and see. That will not be proper, right? Okay, let's just try something and see. Let's just try something and see. So we call in the health here. So now, when you look at the structure you see here, you see that the health also have as an error term, right? Which means that health is now tend to be what? A dependent variable. Health is tend to be a dependent variable. So now take a look at this and this. Let's just run it. Let's just estimate it and see. Let's estimate it and see. So we come to estimation this, and then we say we agree to all these things, and then we estimate. Who estimates style? Good, fine. Okay, we are not disappointed. The variable did not disappoint us. It's run. It's run. Okay, now take a close look at this whole equation here. Take a close look at this equation here. Now, you can see that the introduction of the mediation analysis, the mediator, which is health, okay, this is telling us direct that import impact the mediation, which is health, at 0.7737, and then export impact the health at 0.087, and then health direct to TFP is 0.024 with this one. Now, let's view it at the standardized form. With the standardized form, it's now looking clear for you to see at the standardized form here. It's looking clear for you to see at the standardized form. Now, we have performed a mediation analysis in this system. Now, let's go back to our variable view, the output view. Now, you notice when we run the first analysis, right? We run the first analysis. It says that output of the import to TFP is this, okay, which is significant. And the export to TFP is this, which is also significant. Okay, here, what do you notice here? In this whole analysis, you will not see R square. You will not see R square. You will not see adjusted R square. In structure equation modeling, you will not see the R square or the adjusted R square, whatever. You will not see that. Okay, that is with the structure equation modeling. Okay, with the structure equation modeling. But if you are running it using the ARDL estimator or sequential ADL analysis, you will definitely see those things over there. But this one, we are using structure equation modeling straight. Now, you see that the result here, right, is different from the result here. Okay. Now look at the variable, the coefficient of import is 0.001316, and then the import here is 0.00043. This. Okay. Now it means that when we introduce the mediator here, this is what it's telling us. Now, when you see the direct effect, it's only just one table like this is giving us. Just this is giving. But when you see the mediation analysis, it's telling us different thing. Okay. First of all, it's telling us the direct impact the direct impact of this, the health to TFP, the direct impact of import to TFP, the export to this. And now it's also telling us again that since it's mediation analysis, import impacting health is different. And they are also significant in their way. And then it's now telling us the variance or the stochastic stem of each of them, each of the self-dependent variables. Now, you see that there is a different, there's the coefficients changes with the addition of the mediator. The coefficient change with the addition of the mediator. So when you are running your analysis, you run your direct effect. You don't, when you include the mediation effect, you don't expect to see the variable the same. Okay, the variable the same. Next lecture, I will give you the criteria of mediation, the criteria of moderation, what you should expect, what you should not expect, what make it valuable, what make it not valuable, and then all other tests you need to perform during the moderation analysis. All right. Our time is fast spent. Our time is gone. So I'll pause here. If you have a question, contribution, you can add. Today is like I'm the one doing the show, which I'm not happy. Next time you all do the show with
Hello,
me.
doctor.
Say again.
Hello.
Hello, please, you can come in.
Please, can you go back to your screen? The one for mediation.
I'm here.
So we have direct and indirect. So the first phase of the research are the direct, right?
Yes, please.
So the second phase is the one for mediation.
Yes, please.
Okay. Thank you.
So
I have a contribution too on the
okay.
what is referred to constants on STATA. On smart PLS, we revert them to formative.
Formative.
Yeah.
Okay. So you see, smart PLS people are here. You have to tell us that they don't call it constant. All right. Any other question or comments before we call the class to an end?
Hello, please, I have a question.
Joan, you can ask your question.
With regards to the log, you asked the assignment, you asked us to also find the log. So
you are a bad student. You waited for me to finish the class before you brought this thing. I'll get you. You see what Joan is doing? She waited till we got to the end of the class before she went to show us.
Not to expose us.
Yeah, so Joan, you are a good student. Thank you for the exposition.
Yeah, so with that, we will just write generate, then we'll put all the variables there or what? Like we'll do it like we did the regression.
Yes, so yes, you generate the log separately and then you run it on it.
Okay. So you
next class, and please remind me to do it first, to do it first so that everybody can see.
Okay. Thank you very much.
Okay. Any other question?
Yes, I have another one. Please,
Come with
like
your
every
question.
day when I do it and I save it, but when I come back, it will open and it will open afresh. So I have to always drop this and do all that. Can't I keep it like all that I've done and continue and continue? How do I save it that I'll come and get it back again?
You see when you come here, right?
Yes, please.
Look at the screen. Save. Okay. Then I can save it. You see where I've been saving my work, they are all STATA work. See how it shows. Okay, so when I click save like this. I name it. Fine. It's a STATA file, so it's saved here. Okay, it's saved. So let me close it, right? You have not saved the change you have made to the SM department. Do you want to save change before? Yes. Okay. So structure equation model 1. Is saved. So it's closed. Now, so let me close all these things. Okay, so I reopen STATA, right?
Okay.
I'm relaunching STATA. Then I come to open here. Okay. Then I look for my results. Oh, I made a mistake. I did the wrong saving.
Yeah, you save it
I
as a
shall
data.
put it in the file. Yes, I made a mistake. Oh, come on. I made a mistake. Please, you can save it. Come on. So all the work we did is off.
Mhm.
It's off. It's off.
But if we were to save the
It's
new
off. It's
file, we
off.
can run it again. But I feel
We
that
can run it again.
yeah, but
Yeah, we
when you
didn't
are
run. We didn't
but
save
when
it.
you are
So
saving the output, you ought to go to log before you come to begin. Then you can save. Because if you
save
don't
it.
do it like that, you'll not be able
That
to
was the
save
wrong.
the output.
Sure, that was the wrong. That was the wrong. That's why I said I saved it wrong. Joanne,
Yes, please.
the next class about.
Oh, okay. Okay.
Mm.
Because I do the same saving you said. And when I do it, they will tell me to put in licenses, whatever, initialize licenses.
Okay, right. All right. All right. So thank you, ladies and gentlemen, for your time today,
Thank you, sir.
for boring. And then I
Thank you.
believe my boring is
It's worth it, sir. Yeah, it's an eye opener.
my boring is impactful. So
Today you are a good teacher, you know fast.
today I'm not fast. I'm able to do it as easier. All right. So
Thank you for that.
There.
Yes, sir.
Will you give us work to do so that we will present on Friday?
Hey.
They have work to do. They have work to do. They have work
We
to
have
do.
a lot of work to do.
They have work
Okay.
to do. Please. Okay, adding to your work, run a structure equation modeling.
Hey.
Sharon, you have to add it to your work.
Then you have to send us the data because what we have is
But the data I gave you the last time, you ran it, and some of you are giving me different thing altogether, except some people. All right, don't worry, don't worry. I see what I can do.
yeah. So we want
So we
the
meet.
new data
You want
for
the new
the
data?
for the SEM.
Yes.
Okay. I'll put it on a page.
All right, sir. Thank you very much, sir.
All right. Okay. So, gentlemen, ladies, thank you for the time. Thank God that people say I'm good teacher. I didn't rush them last. Sharon, please, your personal assignment.
Bad.
Sharon,